Every AI model you've ever used, ChatGPT, image generators, self-driving cars, they all learn the same way. They start with a terrible guess, measure how wrong they are, and adjust over and over. And the simplest version of that process, it's something you already know. Finding the best straight line through a cloud of points. Let's break it down. Imagine you have data. Let's say house sizes and their prices. Each house is a point on this graph. Size on the x-axis, price on the y-axis. Now here's the question. If someone tells you the size of a new house, can you predict its price? Your intuition says draw a line that fits the data and read off the prediction. But which line? There are infinitely many lines I could draw. We need a way to find the best line. And to do that, we need to define what best means, mathematically. Any straight line can be written as y hat equals w times x plus b. W is the slope, the weight. How much does the price change when the size increases by 1 unit? B is the y-intercept, the bias, the baseline price when size is 0. So our job is simple. Find the values of W and B that make this line fit the data best. But how do we measure fit? That's where the magic happens. For each data point, the error, the residual, is the difference between the actual value y and the predicted value y hat. Some residuals are positive, some are negative. If we just add them up, they cancel out. A line that's wildly wrong could still have errors summing to 0. So we square each error. That makes everything positive, and it punishes big errors more than small ones. The total error, the loss, is the mean squared error. L of w, b equals 1 over n, times the sum from I equals 1 to n of yi minus wxi plus b all squared. This single number tells us how bad our line is. A big L means a bad fit. A small l means a good fit. Our goal, minimize L. And look at this. When we plot L as a function of w and b, we get this beautiful bowl-shaped surface. There's one bottom, one minimum. That's where the best line lives. So how do we find the bottom? We could try every possible w and b, but that's infinitely many combinations. Instead, we use an algorithm called gradient descent. And this is the core idea behind all of AI training. Here's the idea. Start with random values of w and b, compute the loss. Ask, if I nudge w a tiny bit, does the loss go up or down? Move w in the direction that makes the loss go down. Do the same for b. Repeat. Mathematically, which direction is downhill is given by the gradient, the vector of partial derivatives. Don't worry about memorizing these formulas. The key insight is, the gradient tells you the direction of steepest ascent. So we go the opposite way. This alpha, the learning rate, too big and you overshoot the minimum, too small and you take forever. Watch this. Step by step, the line gets better, the loss decreases. The prediction improves. That is gradient descent. And that is exactly how ChatGPT, Stable Diffusion, and every neural network learns. The loss function is more complex. The parameters aren't just w and b, there are billions, but the principle is identical. Linear regression is a model with 2 parameters. W and b, GPT-4 has over 1 trillion parameters, but the training loop is the same. Make a prediction, measure the error, compute the gradient, update the parameters, repeat billions of times. Every breakthrough in AI, transformers, attention mechanisms, diffusion models, is an innovation in step 1, the architecture, or step 2, the loss function. But steps 3 and 4, pure calculus, the chain rule, gradient descent. So if you understand what we just did with a simple line, you understand the engine of AI. Next time, we'll go deeper into gradient descent. What happens when the surface isn't a nice bowl, why AI training can get stuck, and how modern tricks like atom and momentum solve that. If this made something click for you, subscribe. I'm a math teacher, and my goal is to make the math behind AI as clear as the math I teach my students every day. See you in the next one.